morning, sir.
So today we are going to teach you about H-bridge technology and how it relates to inverter production. How we use it to produce inverters.
Okay, sir.
So H-bridge technology, as I've given the assignment before, you guys must have known one or two about it. It is all about using it to change polarity, okay, of a particular load. I will explain more after drawing this diagram for you. I'm about to draw the diagram of H-bridge arrangement. Alright, we have four switches here. Switch A, switch B, switch C, and switch D. Alright, these four switches are meant to control only one load. This load here. Load. I'll call it L. Now, in this load, I cannot say that this side is positive or this side is negative. Let me explain why. Right now, I've sent negative through here and I've sent positive through this point. Alright, through this upper side. I've sent positive here. Now, naturally, negative is going to be evident from this negative input point till the beginning of the switch C and beginning of switch D. Alright? The same will go here for positive. Positive will be evident till the beginning of switch A and until the beginning of switch B. Alright? Right now, at this load point, which is at the end of switch A and end of switch C, and then also end of switch B and end of switch D, there is no power here at all. No plus, no minus. Because the negative ended here and the positive ended here. So, any switch that we allow, any switch that we power on now, we now send the polarity of which it is carrying to the point where it is. Let's say, for example, we on switch A. If we on switch A, the positive in this line will rush and enter this point. So let's call this point Q and this point S. Are we there? Alright, we'll see that the positive at this point that is coming from this positive side will rush into what? Into point Q. Which means the beginning or the end of switch C will have positive. While the beginning of that switch C will have negative. Am I correct? At this juncture, after on the switch A, you now on switch C, you are in effect bridging the system. That is a very big problem. The next thing you are going to hear is explosion if it's a very big battery system you are using to power this, okay? So, but that's wrong. So you have to on only switch A. Now, if you on switch A, Q will be positive, all right? Which is the one of the terminal of the load. In that case, this terminal of load has positive. Remember, in all appliances, we need positive and negative. Is it not true? So that the load can work. If you want to power a fan, you need to send positive. You will also send negative. If you want to power a bulb, you need to send positive. You will also send negative. If you want to power anything in electricity, it must be positive and negative. So now, by only switch A, we will send positive to this terminal, to the terminal of load, which is the Q point. Alright? Now, we want to send negative. What are we supposed to do? Should we on switch B? No, because if we do that, switch B is still going to send positive. Are we there? What do we need to on? Should we on switch C? No, because if we do that, even if switch C will send negative, or it will be sending it to the wrong time, the wrong point. You see, because positive is already here. We do not need to send negative to the same place where we send positive. Are we there? Now, what we need to on is switch D. Because switch D is now going to allow this negative to rush to the second terminal, which is the point S of the load. Are we there? In that case, when switch A, let's say now A plus D is equals to S is equals to negative, and then Q is equals to what? Positive. Are we together? Are we together?
Yes, sir.
So at this first scenario, when A and B is on, S will be positively charged. All right? And then, sorry, am I correct? No, S is going to be negative, and then Q would be what?
Positive.
Are we there? So we've achieved one polarity. Okay? Now we want to change the polarity. But before we do that, let me remind you, when you were very small, you used to play with this thing we call Motorola. You know, it is inside the DVD. Sometimes DVD, VCDs and stuff. You know, as a kid, we like going inside and bring it out. You know, plug it on your battery. It will roll clockwise. You know, remove it from your battery, turn it the other way. It will start rolling anti-clockwise. So that's exactly what we want to do. What you are doing then when you were younger was that you were simply changing polarity. Okay? You were sending positive to positive, negative to negative, and then the motor roll clockwise. Now you want to change the polarity, you have to now send negative to positive and positive to negative. The motor will roll anti-clockwise. But this only applies for motors, DC motors. It doesn't work for any other thing. If you use it for any other thing, it will destroy it. Are we there? It will destroy it because most appliances of electricity do not tolerate change of polarity unless they are AC devices. Alright? And we're not talking about AC devices now. We're talking about DC devices. That is, devices you can power with your battery. Are we there? Are we together?
Yes.
Good. Now we want to go to the second instance. And then the S terminal to be what? Positive. So what do we need to do? We need to switch off this A and switch off this D so that the system come back to this state. Are we there? Then we will now come and on B. If we on B, the positive will flow to the S terminal. Are we there? Okay? And then we will now on C. The negative will flow now to the Q terminal. Are we there? So it's quite simple, you see. So it's more like A and D, you off it.
B and C,
you off it. So let's do that this thing again. We'll now say B plus C is equals to S now will be what?
Positive.
Plus. Then Q will be what? Negative. Are we there?
Yeah.
So basically, we are getting the opposite of what we got in the first scenario to the second. So this is how H-bridge technology works. Now, what do we really want to achieve? We want to change light. What is AC? Remember, we want to build an inverter system, all right? An inverter system is a device that converts a DC current or DC power into what? AC power. Is it not true?
True.
That is it. Now, what is DC power? DC power is that type of power that just flows in one direction. It doesn't have change of polarity and stuff like that. But AC power is a type of power that actually changes polarity with the time. And this is what we want to achieve, changing of that polarity. And that's why we are here with this H-bridge technology. With H-bridge technology, the terminal that was positive now becomes negative later. The terminal that is negative later is positive now, and it keeps changing. If we were powering a DC motor with this, all right, at the first instant, the DC motor may be turning clockwise. At the second instant, the DC motor will be turning anti-clockwise. So let's say you are building a robotic car and you want the vehicle to be going forward. So what do you need to do? You power this one and the DC motor goes forward like this. At some point, you want it to be going backward. You change the polarity, right? It starts coming back. But this time, we don't want to power DC motor. What we want to power is a transformer. Alright, now what is a transformer? A transformer is that device that is used to step up or step down AC voltage. You get the point now? AC voltage. Only AC voltage. So which means if transformer was a device that is used to step down, step up or step down, both AC and DC, we wouldn't need this arrangement here. We would have just carried our battery and connected directly to transformer. Do you get it? And then transformer will do the job for us. But if you send your battery to transformer, it will not understand it because transformer only understands the language of what? AC. And the battery is what? DC. And do you get the point now? So in this H-brick technology is where the DC is actually being converted into AC. Do you get the point? Now we are going to remove this load from here and change it now to a what? A transformer. This is an inductor though, right? If you now want to call it a transformer, we'll put it and draw more here, but I don't want to make it too confusing or ambiguous. So this is our alright, transformer now we see it as an AC voltage. Alright? Remember, the voltage you are sending in from the battery is what? 12 volts. Alright? It could be 12, it could be 24, it could be 48, it could be 36, and so on and so forth. Alright? So we are using 12 as our reference for now. So let's say one battery, plus and minus. So we send the plus here, we send the minus here. Are we there? Are we there? Yes. So let me clean these ones up. Clean this plus up and so on. So now the battery is the guy powering it. So this negative flows here, this positive flows here. So 12 volts battery is what we are sending in. So 12 volts is what is coming in. So now once 12 volts comes in, 12 volts it comes in as a DC. Alright, when it is now going out, it is going out as an AC. And once that 12 volts AC enters into a step up transformer, the transformer takes in that 12 and steps it up. And we talked about transformer stepping up ratio the last time we came, right? We talked about that if we have 1:2 transformer, it means if you put a 10 volts in this side, you get 20 here. Okay? If you put 12 volts here, you get 24 here, right? What of 1:10? If you put 1 volt here, you get 10 volts, right? Yeah. If you put 10 volts here, you get 100 volts. Alright? If you put 110 volts here, you get what? 220 volts. What about 1:50? Or let me say 1:20. Alright? It means if you put 1 volt here, you get 20. If you put 10 volts here, you get 200 volts. Are we together? What if you put 12 volts here? 12 times 20 is what, please? 12 times 20. 12 times 10 is 120. That should be 240. So 240 volts is what. And for what we are building, of course, in Nigeria, we have our normal input voltage to be between 220 to 240 volts. So let's, basically, say we choose a 1:20 transformer. So that when that 12 volts is coming in from here, what will happen? 240 volts comes out of the transformer. How does the transformer? Let me remove this transformer from here so it doesn't look. It will be a little bit clearer. All right. Bam. All right. So we know this as our transformer, huh? Are we there? This is our transformer. See the way I'm connecting it. All right. Good. You see these two wires. Instead of being inside, I don't want to put it inside. All right. So this one, connected from point S, all right, towards the input of the transformer, which is the 12 volt side. All right. Are we there? This is 1:20. All right. So we'll send this thing to the 12 volt side, which is here. Or let's remove that 12 volts, send it to the one side. All right, the low volt side of the transformer. Okay. Then this one goes to the other terminal of the transformer. So that at the first instant, when the H bridge is changing its polarity so fast, the current is being sent through these two wires to the what? The transformer. Transformer does the job by stepping it on. Alright, so if 12 comes in here, if 12 volts comes in here, of course 12 volts AC comes in here, it sends that 12 volts AC to this time 240 volts AC. Are we together? 240 volts AC is what is coming down. And this 240 volts AC can now be used in our house and so on and so forth. Are we together? This is the basic idea, the basic arrangement of an inverter system. This is the basic arrangement of an inverter system using H bridge. Do we understand this? Do we understand this?
Yes, sir.
Now, one more thing I'm going to say, two more things as a matter of fact. These are switches, right? To externally operate. Not so? Yes. You have to externally operate switches. So now, does it mean we are going to employ 4 people? One of them will be pressing A, the other one will press B, the other one will press C, the other one will press D. So that when A and B guys don't know, A and D guys does their own,
B and C
will do their own. Even if we could do that, it will not be possible to achieve what we want. Reason: in our electronics access between 50 to 60 hertz, which means 50 to 60 times in 1 second must these switches happen. Please let me come again. We know this changing of polarity is needed, right? We need the plus and minus in the point Q and the point S. All right? Now, we are also saying that it has to be as fast as 50 times in 1 second. How long is 1 second?
50 times.
Now, before 1 palm is completed, you must have done this thing 50 times. Not just one, you must have done the A and D relationship 50 times.
B and C
relationship another 50
times.
Man, is that not quite fast? Can human being do that? No. So then what do we use? These switches were just to slow down the way the thing was working for you. But now we need to put a faster switch. Alright? Things that can automatically do this work in a faster way. Do you agree with me? Do you agree with me? I'm not hearing your voices. Do you agree with me?
Yes, sir.
Beautiful. Now, we know of one type of switch in electronics. You know, in school they teach us that something is used as a switch and also as an amplifier. What is that?
Transistor.
Transistor. Thank you very much. That transistor is what we would like to employ here. But we would like to employ a special type of transistor called MOSFETs. MOSFETs, full meaning: metal oxide semiconductor field effect transistor. Quite a long name, isn't it? But of course, that's the name it is. So now, that MOSFET are special MOSFETs because they are powerful and they waste less power. You know, they dissipate less power as heat. A very small tiny MOSFET can actually switch in high current, sometimes up to 200 something amps. Only one MOSFET. And yet, their heat dissipation is quite interesting, but it doesn't, produce more. You know, when electrical devices are producing heat, they are wasting power through heat losses. We were talking about heat losses, right?
Heat losses.
And so on and so forth. So now we're going to replace this with transistor. But I don't want to draw the diagram of MOSFET. So this is the transistor diagram right now. Alright, let me clean this equation side off. So right now we know that transistors are not the type of switch that you use your hand to operate. Like bam, 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 you press it and so on. That is not what transistor is. Transistors are powered also by electricity in order for them to either activate or deactivate their terminal. Let me explain in a little basic way. You see, transistor has 3 terminals, okay? 3 terminals. 3 terminals. One of them is called collector. The other one is called emitter, and the other one is called base. Now, this is an NPN transistor, all right? Now, what happens? If you send a particular polarity of electricity into the base of a transistor, the collector and the emitter are joined together. I'll come again. Normally, the switch is like this. Alright? So when you press this, the 2 terminals are joined together. Alright? But this time around, if you send, not pressing, you're not pressing now. If you send a particular polarity to this base terminal, the collector and the emitter are joined together. This transistor, when you send a particular polarity to it, let me not go too wide. You see, this is an NPN transistor. It means negative, positive, negative. So when you send positive to the base of this transistor, this emitter and collector will join together as if it is a switch. When you remove that positive, the emitter and the collector will separate. That is how transistor works. Do you get the point now? And so we have employed 4 transistors here. So these 4 transistors, we will merge D, we'll jump this wire, we'll merge it with what?
A.
With A. I would like us to also jump this wire. Okay, we'll merge it with A. Okay? And then we will now come again. We'll send C and do what?
B.
Merge it with B. Forgive my drawing, and I hope you understand. So we'll send it there. Now we will just have only 2 terminals. And what are those 2 terminals? This is terminal
AD.
This is terminal what? Terminal
B.
C plus B. And this here
AD.
is terminal A plus B. Alright? So what simply happens here is this one on, this one off. This one on, this one off. Because if this one on, positive will enter here, positive will enter here. Alright? Is it not true? Yes. And so if the polarity is in one direction, that is plus or minus. If this one off, this one, because this one has to off. If it doesn't off, if the 2 of them on at the same time, it's a problem. It simply means you are owning all the 4 transistors at the same time. That means you are bridging
The system.
You get the point now. So this is the basic explanation of
H-bridge.
H-bridge technology. And now, this tool is being sent to a device that we call an oscillator.
Oh.
The oscillator is now the device that actually, you guys must have been taught multi-vibrators using NE555. You know, that IC can switch in 3 modes: monostable multi-vibrator and then off-in. Alright? So, but of course, 555 has only one output, that is on-in and off-in. And so for applications like this, we could use SG3524. It's another IC which has 2 outputs. If one on, the other one off. If one on, the other one off. And that can be very fitting for this. When you send it from here to here, it starts powering. And then outputs are coming out. But it will not be pure sine wave. And that is what we are going to be doing the next time when we come. You see, pure sine wave technology is the one closest to the one we are using, the general public supply, the NEPA that we know. All right, their output comes from pure sine wave. It helps your electronics works better, your fridge works better, your fan works better. Okay, this is more like a square wave system because of the IC that is switching it. LG3524, 3525, and many other ICs like that, 40, 47, and so on. They are all square wave ICs. This is why we are going to introduce yet another type of arrangement on how to switch in a square wave or in a sine wave mode. And that is how we're going to build our inverter. Now, assignment to everybody who is watching this video. Go and give us one way we can achieve a sine wave using H-bridge technology. One way we can achieve a sine wave using H-bridge technology. When you are done writing this, write it, explain it, and send it back to us. Thank you very much. Write your name on it when you are sending, so we know you. Thank you very much, and see you next time.